Hi, Assalamualaikum and a very good day to Dr. Rossidah and everyone. We are from N4CS2496B1 and would like to present about solving Sudoku using graph theory. Meet our team members. Firstly, it's me, Nadia Syakirah binti Muhammad Zain. Next, we have Sofiatun Nadhirah binti Abdul Razak. Then we have Syuhadah binti Naseb. Lastly, we have Zatie Nurdiana binti Zahrinnuddin. Introduction for Sudoku. What is Sudoku? Based on Simone's 2005, Sudoku is a puzzle that involves filling in a 9 x 9 grid with numbers from 1 to 9. The goal is to complete the grid in a way that each row, each column, and each 3x3 block contains distinct numbers. Unlike some logical puzzles, the difficulty in Sudoku goes beyond simply finding a solution. Well-constructed Sudoku puzzles have a single unique solution, and the challenge lies in discovering it through logical deduction without resorting to guesswork or searching.
Next, I will explain to you about graph coloring. Lewis 2016 suggests that a graph can be defined as a collection of objects, or known as vertices, with some of object of vertices connected by links or known as an edges. Based on MAT668 et al. 2010, by considering a basic graph as G equal to VE, which V stands for vertex and E stands for edges, a vertex coloring of G gives each vertex a color by ensuring that the neighbor have different color of vertex. So, based on both introduction, knowing that in this study, we will focusing on solving the Sudoku puzzle by using graph theory. Therefore, in this study, we came up with two different problem statements. First, Sudoku puzzles are likely to a graph theory, but can we prove it by using the graph coloring solution? Next, most of the Sudoku game has three different levels of difficulty: easy, intermediate, and hard. Most of the people can pass the easy and intermediate level in a short time, but when it comes to the hard level, some people need more time to solve it.
I will continue the presentation. So, this is our sample of Sudoku puzzle. So, we choose hard level for our solution. Next is objective. So, in this project, we have two objectives. For the first objective is to identify how graph coloring solve the Sudoku puzzle. And second is to determine the faster alternate method for solving hard level of Sudoku puzzle.
Before proceed to the graph coloring, first we must make the adjacency matrix of the problem. The adjacency matrix is made when if a vertex connected to another vertex, we write 1, otherwise 0. For example, based on the figure above, we can conclude that vertex 1 have connection with vertex 2, 3, 4, 5, 6, 7, and 8. In the context of a standard Sudoku puzzle, we need to assign a unique number from 1 to 9 to each cell. A vertex is represent each of cell in Sudoku puzzle, while the edges is connection between each cells in every column, row, and grid. Since the number from 1 to 9 can be represented as colors, 9 distinct colors are required to solve the puzzle. This requirement aligns with the concept of chromatic number in graph theory. Next, after finding the adjacency matrix and chromatic number, every row, column, and grid should have 9 distinct colors since we want to assign number 1 to 9. And lastly, we can solve the Sudoku. For instance, green is for 3 and blue is for 1, and same goes to the other numbers. Therefore, this is the Sudoku solution.
So, the conclusion of this project is graph coloring is one of the alternate methods to solve hard level of Sudoku. By assigning a color that represents a number, maintaining the constraint the adjacent cell must have a different color.
Here is the list of reference that is used in this project. Lastly, these are our appendices. These are the coding that used to solve the Sudoku. This is appendices page 2, page 3, page 4, page 5, and page 6. That's a wrap from us. Thank you for watching.